Today we're going to talk about lengths of chords. So first we're going to look at segments on chords. Segments of a chord are the segments formed on a chord when the two chords of a circle intersect. So the segment chord theorem states that if two chords in a circle intersect, then the product of the length of the segments of one chord is equal to the product of the lengths of the segments of the second chord. So remember, product means multiplication. So if we look at these chords that we have right here, which are C, R, and D, H. So again, it says the product of the lengths of the segments of the chord. So we can split up the chords into two segments. So if you look at the yellow highlighted one, we have CE and ER would be the segments. So it's saying that CE times ER is equal to the product of the length of the second chord. So DE times EH. Note that CR, the length, and DH, the length, is not congruent. So the product of each of the different segments are equal, but that doesn't mean that they are congruent. So I just wanted to point that out. So let's go ahead and look at some examples. So we're solving for X. So we have two chords that are intersected in the circle, and we want to figure out X. So we know that the product of this chord right here, the segment length, so the segments are 3 and X, so the products of 3 and X has to be equal to the product of 9 and 6. So that would be 9 times 6. So when we do this, we get 3x equals 54, divide by 3, and x is equal to 18. So for the next one, or before we get to the next one, just to show you, so notice that 9 plus 6 is 15, and 3 plus 18 is 21. So notice those are not congruent. So I just wanted to point that out because often students try to set those equal when they're not. So if we look at the next one, we have the chord AC intersecting the DH. And so we know that the product of the segments has to be equal. And first we want to solve for X. So these are on the same chord. So 2x times 8 has to be equal to 32 times 14. So when we solve, we get 2 times 8, which is 16x, equals 32 times 14, which is 448. Then the next step would be, of course, to divide by 16. So we get x is equal to 28. So BD is this length right here. So if we want to find the length of BD, that's going to be equal to 2 times 28 plus 8, because we're adding that other segment when we're finding the length. So when we add that, we end up with BD being equal to 64. All right, so let's go ahead and look at the next one. So we want to solve to find X first. So we have this chord. So if we want to set that equal to the product of these segments, we would have 6x is equal to 10 times x minus 8. Make sure you put that in parentheses because you're going to have to distribute. So 6x equals 10x minus 80. Subtract that 10x. So we get negative 4x is equal to negative 80. And divide by negative 4, and x is equal to 20. And now we want to figure out what the length of AB is equal to. So AB would be equal to 20 plus 6. So that gives us 26 because it's x plus 6. And CD is x minus 8 plus 10. So x is 20. So 20 minus 8 and then plus the 10 would end up giving us 22. So go ahead and pause the video and see if you can do number 4 on your own when you're done on pause, and we'll check our work. So we have dB, which is x times 2x minus 1, has to be equal to AC, which is x plus 2 times 2x minus 4. So the products of the two segments have to be equal. So when we multiply, we get 2x squared minus x is equal to, and over here we're going to have to FOIL. So we get 2x squared minus 4x plus 4x minus 8. So combine like terms. So 2x squared is equal to 2x squared. Notice that the minus 4x and plus 4x are going to cancel out right here. So we have minus 8. And then the next step I could do is subtract 2x squared from both sides. Notice that when you do that, these end up actually canceling out. So negative x is equal to negative 8, which divide by negative 1, and x is equal to 8. So now that we have that, we can find AC length. So AC length is going to be, we're plugging in, we have x plus 2 plus 2x minus 4. So we're plugging in 8 for x. So that gives us 8 plus 2 plus 2 times 8 minus 4. And when we add that, we get 22. And then BD length would be equal to x plus 2x minus 1. So 8 plus 2 times 8 minus 1, which ends up giving us 23. All right, so let's go ahead and see if you guys can do these next two on your own. When you're done, you can unpause the video and we will check your work. So looking at the next one, so we have this length product, which is x times x plus 8, has to be equal to the product of this length. So 6 times 8. So we're going to solve for x by multiplying. So we get x squared plus 8x is equal to 48. Notice here that we have a quadratic term, a linear term, and a constant term. So when that happens, remember you want to set your equation equal to 0 because it's a quadratic equation. So we set it equal to 0 by subtracting 48 to the other side. And you can factor or use the quadratic formula to solve. Factoring tends to be a lot faster, but if you don't remember how to factor, you can always use the quadratic formula. So we want factors of negative 48 that add up to 8. So factors of negative 48 that add up to 8 would be plus 12 and minus 4. And now that we have our factors, we can set each factor equal to 0 to solve. Here we get x equals negative 12, and here we get x is equal to 4. Well, we can't have a negative side length. So that means we're going to use x equals 4 to help us solve. So then if we want to find AC length is equal to 8 plus 6. So 8 plus 6, of course, is 14. And we want to find BD's length. So the length of BD is equal to x plus 8. So in this case, we end up with 4 plus 8, which gives us 16. And same thing for the last one. So we have this segment product. So x times x plus 4 is equal to the product of these two segments, which is 2 times x squared minus 16. So we get x squared plus 4x is equal to 2x squared minus 32. And then I would notice I have quadratic, linear, and constant terms. So I'm going to first get the quadratic terms together by subtracting x squared. So we have 4x is equal to x squared minus 32. And again, I have a quadratic, a linear, and a constant after combining my like terms on both sides of the equal sign. So therefore, I'm going to set this equal to 0 by subtracting the 4x. So 0 equals x squared minus 4x minus 32. And again, I have a quadratic equation, so I can either solve by using the quadratic formula or factoring. So I'm going to go ahead and factor. I want factors of negative 32 that add up to negative 4, which would be negative 8 and positive 4. And I can set each factor equal to 0 and solve. So here we get x is equal to 8 and x equals negative 4. So x equals 8 would be our solution. So then AC length would be 8 squared minus 16 plus 2, which gives us 50. And BD's length is going to be x, which is 8 plus x plus 4, so 8 plus 4, which gives us 20. And that is it for lengths of chords.